In this tutorial, I'm going to be walking you through the data collection and the analysis procedure. Data collection and analysis refer to the systematic process used to gather, organize, and interpret information in a research study in order to answer research questions and test hypotheses. Data collection involves using the methods such as surveys, interviews, observations, and experiments, whereas the data analysis involves cleaning, coding, and examining the collected data using qualitative or quantitative techniques in order to identify the patterns, relationships, or the trends. First, data can be divided into two groups, primary data and secondary data. Primary data refers to the original data that is collected firsthand by a researcher specifically for a particular study or research objective. Methods for collecting primary data include surveys, interviews, experiments, and direct observations. It is worth noticing that collecting primary data can be time-consuming, costly, and sometimes even logistically challenging. Secondary data refers to the information that has already been collected, compiled, and published by someone else. The most prominent examples would be government reports, journal articles, organizational records, and online databases. In contrast to primary data, secondary data is typically easier and cheaper to obtain, but it may not perfectly match the researcher's need, and that could be highlighted as a disadvantage of secondary data. Triangulation is the process where you use multiple data sources, methods, or perspectives to study a phenomenon. So the main goal is to increase the validity and reliability of the findings and provide a comprehensive understanding of the research problem. There are three types of triangulations. Being the first one, data triangulation, it uses different sources of data to study the same issue. For an example, collecting information about student stress from surveys, interviews with teachers, and school attendance records. And the next one is method triangulation. It uses multiple research methods to examine the same phenomenon. For an example, combining questionnaires, focus group discussions, and direct observations to study employee satisfaction. And the third one is investigator triangulation. This process involves multiple researchers analyzing the same data to avoid individual biases. For an example, 3 researchers independently analyzing interview transcripts to identify common themes in customer feedback. Alright, we have come to the chapter 8, which is quantitative data collection. Quantitative data collection is the systematic process of gathering numerical information that can be measured, counted, and statistically analyzed. It basically helps researchers identify the patterns, relationships, and trends among variables. Common methods for collecting quantitative data include structured surveys with closed-ended questions and experiments with controlled variables and standardized tests or measurements. Surveys and questionnaires are widely used as quantitative data collection methods. These questions are often closed-ended, such as multiple choice Likert scales or rating scales, which makes it easy to quantify responses. And the popular tools for designing and distributing surveys includes Google Forms, SurveyMonkey, Qualtrics, as well as Microsoft Forms. And the second method is experiments and controlled observations. So this is basically the manipulation of one or more independent variables under controlled condition to observe their effects on the dependent variables. This method helps researchers to test cause and effect relationships. And the controlled observations are systematic observations conducted under specific conditions where variables are carefully monitored. The most common tools would be lab equipment, observation checklists, timers, and sensors. And the third method is accessing datasets and secondary data. So this method is basically performed using pre-collected numerical data from previous research or records to analyze new questions. The common tools would be government reports, census data, organizational records, and online databases. Since surveys and questionnaires are pretty much elemental in a research study, it is compulsory for you to understand on how to create a proper design. This is a step-by-step guidance we have created for you to follow along when you create your own questionnaire. And the first step is to identify or to define your research objectives. So clearly state what you want to find out and identify research questions and variables, and decide whether your questions will be quantitative or qualitative. For an example, measure the relationship between Instagram use and sleep quality among high school students. And the second step is to plan the questionnaire structure. So basically you can dedicate a separate section for the introduction where you can briefly explain the purpose, estimated time, and ensure the countermeasures you have taken in order to protect the respondents' anonymity and the confidentiality, and other sections into logical groups such as demographics, social media use, sleep patterns. Those could be the objectives of your research. And you have to also focus on the question types. Use appropriate question types. You could possibly use multiple choices, checkboxes, linear scale, drop downs, and short or long answers, but that's optional for qualitative insights. Since we're using Google Forms to create this questionnaire, you go to Google Forms and click a blank form to start a new survey, and enter the form title and description, and you can next add questions by clicking the plus buttons, which I'm going to demonstrate later in this video. And the fourth step, to use logics and sections. This is actually an optional step where you can divide the survey into parts for the flow and apply conditional logics like code section based on answers is useful if certain questions only apply to specific participants. And the fifth step is to customize the form design. You can work on your visual aesthetics to make it seem more appealing by adding images or changing the typography and etc. The sixth step is to test your survey, and seventh step is to distribute your survey. For example, you can share it through WhatsApp groups to reach students, or use another social media platforms to expedite the distribution process. The eighth step is to collect and analyze responses. This is the survey design checklist we have created, so feel free to use this checklist when you're creating your own questionnaire. And now I'm going to show you how to create a questionnaire using Google Forms. So this is the user interface when you create a blank form. You can Google this keyword as Google Forms, and you go to the first link and create a blank form. And this is basically where your title is going to be. As an example, I'm going to title this Evaluation of Customer Satisfaction. And you've got options here to make changes to the typography. Into the form description, you can basically include the introduction and the purpose, objectives, as well as the ethical standards you have followed in order to protect the respondent's anonymity as well as their data protection. You can add this plus icon to include new questions to the current section, and also you can create multiple sections in your questionnaire in your Google form in this bottom icon. Having multiple sections, you can better organize your questionnaire. For an example, I can rename the section to as demographics and add questions into that section. Currently, I have selected multiple choices as the answers type. You can also change to linear scale, checkboxes, and etc. And you can tick this required toggle button to basically necessitate answering the question. And you can use this eye icon to basically toggle between the review mode, and then you can start responding section wise. This is the questionnaire I produced for research purpose regarding the deep text and deep face technologies in Facebook. And this study was based on 3 main objectives, and you can see I have used section to split those objectives for a better organization of the responses. And also I have used this customization icon to customize the questionnaire, and I have included an image as well as made some changes to the color palette. So once you successfully created your questionnaire, you can use the publish button to publish your questionnaire and distribute it using the link. And these are the visual demonstrations of the responses I have received for this questionnaire. You can basically use this View in Sheets button and open the responses as a spreadsheet. Once you click it, it takes you to Google Sheets from Google Workspace. And these are the variables, or in other words, the questions they have used and the received responses. And you can literally open this up with Microsoft Excel. All you gotta do is to click the file option here and download it as an Excel file. And next up we have chapter 9, qualitative data collection. So qualitative data collection refers to the process of gathering non-numerical information, unlike quantitative data collection. This provides in-depth insights into participants' experiences and perceptions, motivations, or the behaviors. As the common methods, you can use interviews, focus groups, observations, and documentation. An interview is basically a one-on-one or small-scale conversation you're having with participants in order to gather detailed personal insights. And the focus group is a guided group discussion, unlike a one-on-one or small-scale conversation with a participant. This is solely focused on exploring opinions, attitudes, or the experiences on a topic. The observation involves in watching participants in natural or controlled settings to understand their behaviors and interactions. And the documentation, it basically involves in analyzing existing materials such as reports, letters, journals, or media to extract qualitative aspects of the information. For each qualitative data collection methods, we have created a template where you can use in your own research. For an example, this is the interview guide template. You basically start off by the title of the research study and the participant ID or their name, and the date and time, and the interviewer, and the location and the mode. And following that, you can give a little bit of an introduction to the context. And right after that, you can ask some warm-up questions just to get familiar with your participant. You can basically use these questions like, can you tell me a little about yourself? And how would you describe your typical day, just to know how the regular routine on a daily basis. And then you can jump off to the main research questions to explore the main topic in depth. You can basically use your variables or the objectives that you have set in order to organize these questions. And the probing questions as the next step. So these are the supporting questions where you can use to explore the controversy. And then the closing questions like, is there anything else you would like to share on this topic? And after that, the note section, where you examine or observe about the participant's tone, body language, and the mood. And also, more importantly, you can note down the key points, quotes, and the interesting remarks. And when you're conducting an interview, there are a couple of tips we have prepared, so be flexible. You must be flexible with your participant and allow this participant to speak freely with you while ensuring that you have got all the themes covered. The next thing is to use probing questions to deepen the responses so you can gain more insights about their experiences as well as their deepened perception. And more importantly, you should avoid leading questions or expressing your personal opinions, because you might bias this interview just in case you do so. So it is best to avoid these questions and opinions. And we have come to chapter 10. This is where I'm going to take you through the data analysis and the graphical representations. The data analysis is the process of organizing, examining, interpreting, and transforming of collected data to discover meaningful patterns, relationships, insights that answer research questions. This phase involves cleaning and preparing the data, applying appropriate techniques such as the statistical analysis for quantitative data and the thematic analysis for qualitative data. And based on them, the conclusions will be drawn. So the primary purpose of the data analysis is to convert the raw data into useful information that supports decision-making process and test hypotheses and helps researchers understand the significance of the results in relation to the research objectives. Predominantly, the data analysis can be divided into quantitative analysis and the qualitative analysis. As you have already learned, quantitative analysis focuses on the numerical data, whereas the qualitative analysis focuses on the non-numerical data. As a sub-procedure in the data analysis, data pre-processing is the process of where you're going to clean, transform, and organize raw data before you do the analysis to ensure the accuracy, consistency, as well as the suitability for statistical or machine learning models. This basically involves removing errors, handle missing or inconsistent values, and convert data into a format that can be effectively analyzed, such as the categorical data into numerical data. Just imagine you have received Likert scale responses like strongly agree and agree. You can basically convert them into a numerical range to effectively perform the analysis. Later in this video, I'm going to demonstrate how to encode data from categorical values to numerical values. The next topic we're going to go over is graphical representations. Graphical representations are nothing more than the ways of displaying the data in a clear and organized way. The most common methods include a histogram, box plot, bar chart, and line graphs. For an example, a histogram shows the distribution of numerical data by grouping values into continuous intervals, also known as bins, and displaying each frequency with the touching bars. Well, in this case, it is used to understand the distribution, patterns, and the shape. And these are the visual representations. First one, we have bar graph, and a histogram, and a frequency table, and a circle graph, most commonly known as a pie chart, and the line graph, and stem and leaf plot, line plot, box and whisker plot. Out of all these visual representations, the most common ones are the bar graph, line graph, and the pie chart, and the histograms. And also later in this video, I'm going to show you how to create a professional looking data representations after performing data analysis. As you already know, quantitative data analysis is the process of examining and interpreting numerical data using statistical and mathematical techniques to identify patterns, relationships, and trends. There are two most common methods that's being used in this analysis type, and the first one being the descriptive statistics, such as the mean, median, and the percentages. And the next one is inferential statistics, the correlation analysis, regression, and hypothesis testing. And this is the statistical test selection guide. As a step one, you need to know what is the research purpose of your study. For an example, your purpose is only to describe the data. You can use descriptive statistics. Just in case your purpose is to compare groups or test relationships, you can use inferential statistics. And after you identify the relationship between variables, you can use Pearson correlation to identify the independent variable's impact on the dependent variable. For example, study hours and the exam marks. You can also use Spearman correlations when you want to rank the relationships. For example, the satisfaction level and the service ranking. And these are the statistical techniques you can use when you differentiating between groups. If you're comparing only two groups, you can possibly use independent t-test where two different groups are used. For an example, male and female income. And you can also use paired t-test just when you measure the same group twice. For an example, before and after training performance. And just in case you're comparing more than two groups, you can use ANOVA, the analysis of variance. So basically you can compare more than two groups. For an example, sales performance of 3 branches. And when you have to analyze the association between categorical variables, you can use chi-square test. For an example, the gender versus product preference. And the next topic is descriptive statistics. So it refers to the methods used to organize, summarize, and present data in a meaningful way. Basically, this involves in describing the main features of a dataset by showing patterns, trends, and the distributions without making predictions or generalization. The most common measurements in descriptive statistics include mean, median, mode to show the central tendency, the range, variance, as well as the standard deviation, in order to show how data is spread across the dataset. And we have included mathematical formulas for each measurement. You do not have to feel overwhelmed because we're going to use a statistical software to analyze this data, but I think it is best to understand the core concept of what these measurements are actually mean. So there is a meaning for each measurement with a corresponding example for your ease of understanding. So I suggest you pausing the video and see it for yourself. The next technique we have here is the inferential statistics. Inferential statistics are used to make conclusions, predictions, and generalizations about a larger population. It does not involve studying every individual. Instead of that, researchers analyze a sample and apply statistical tests to determine relationships, differences, or the effects. Common methods are t-test, ANOVA, correlation, regression, and chi-square tests. In hypothesis testing, null hypothesis, an alternative hypothesis, p-value, significance level, type 1 error, and the type 2 error, also known as beta error. Basically, null hypothesis is a statement of no effect or no difference that assumes that only observed pattern is due to a random chance. For an example, there is no difference in average exam scores between male and female students. The alternative hypothesis is the inverse of null hypothesis, where a statement that contradicts the null hypothesis represents the effect or difference that the researcher expects to find. For an example, female students have higher average exam scores than male students. And the p-value refers to the probability of observing data or something more extreme if null hypothesis is true. A low p-value is generally associated with less than 5%, and that supports the rejection of the null hypothesis. Just in case the p-value is higher than 5%, it typically fails to reject the null hypothesis. And the next one is significance level, and it's the threshold probability for rejecting null hypothesis, usually set at 5%. The type 1 error is for rejecting the null hypothesis when it is actually true. For example, concluding female students score higher when there is no real difference. And the type 2 error, also known as the beta error, it is failing to reject null hypothesis when it is actually false. For an example, concluding there is no difference in scores when female students actually score higher. And these are the inferential statistics methods. And the first one, we have independent t-test. It used to compare means of two independent groups. And the next one, paired t-test, which compares means of same group at 2 times. And the ANOVA compares means of 3 or more groups. The chi-square test, it tests association between categorical values. And the Pearson correlation, which is the most common one for measuring linear relationship between 2 continuous variables. The next technique is Pearson correlation, which measures rank-based relationships. And the last one is simple linear regression. It basically predicts y from the variable x. I highly suggest you pausing the video and figure this out for yourself because it usually takes a little more time to get familiar with these formulas and their meanings. And this demonstration includes all you need to know along with examples, so this will help you understand everything in one single format. And later in this video, I'm going to demonstrate how to perform a one-way ANOVA analysis regarding the inferential statistics using a data analysis software called SPSS from IBM. And we have prepared a decision tree to help you decide which test to use based on your goals. So the first thing you have to figure out is what is your research goal. Just in case your goal is to compare group means, you should use a comparing technique used for group means. And your goal is to test association or the correlation between variables, you should choose a technique where the association and the relationship related technique. And if your goal is to predict the outcomes, you can use regression. All these statistical techniques outputs data, and so it is important to identify what these data actually mean. You can basically divide these outputs into 4 types. The first one being the test statistics. It basically quantifies the difference or relationships. For example, t equals 2.45, which means it's a high absolute value, greater difference relative to variability. The second one is the p-value. It's the probability of results if h0 is true. h0 is a null hypothesis, like we mentioned before. For an example, p equals to 0.02, which means the 2%, and the p-value is less than 5%, which means that we can reject null hypothesis. And the third one is the effect size. It's the magnitude of difference or association. And for example, coins d equals to 0.8. It is a large effect, practically important. And the next one is a confidence interval. So that's a range likely containing population parameter. For an example, 95% CI, the confidence interval is 95. And the CI excludes 0, which means its difference is significant. You don't really have to be worried about all this statistical related stuff, because at the end of this course you will be provided valuable links to study even more so you can understand the intuition behind all these statistics. These are the statistical software for quantitative analysis. The first one is the most primary tool, the Microsoft Excel. As you can probably know, it's a spreadsheet-based data organization tool, and it's mostly used for calculation averages, exam scores, creating histograms, summarizing survey responses, and I'm going to show you how to encode categorical data into numerical data, as I mentioned earlier in the tutorial. And the next tool is SPSS, which stands for Statistical Package for Social Sciences. It is by IBM, and it's a very user-friendly GUI. And I'm going to make a demonstration out of this software so you can learn the basics and successfully perform data analysis using this software. And next up we have R programming. It is a programming language and it's free and open source. If you're good with coding and programming, I would really suggest you using this R programming language so you can learn even more and the intuition behind these mathematical models. The last one is Python. This is a general purpose programming language and it's the backbone of machine learning and AI nowadays. There is abundance of libraries for statistics and data analysis, so that actually makes the Python as the most reliable and robust choice for data analysis. So Kaggle is an online platform for data science. So there are so many data sets. It's pretty much like a database. You can download data and perform data analysis for practice purposes. As you can see, I have created an account and searched for customer feedback and satisfaction dataset. And there is an overview for the dataset, and it includes about the synthetic dataset designed to analyze and predict customer satisfaction based on various demographic and behavioral factors. And this dataset contains for 38,444 customers capturing their feedback on products and services in a structured format. And it also includes the use case that you can use this dataset with. As you can see, these are the columns of this dataset and it's in comma separated values. I'm going to go ahead and download this dataset, and after that you have to extract it, and then you can open it with Microsoft Excel. And this is the dataset. And now I'm going to show you how to convert a categorical data type to a numerical data type using this country column of the dataset. First, I suggest you opening a blank document in Word and list down the countries respectively and assign numerical values to each country. And after that, go back to Excel sheet, and in the Home tab you can choose Find and Select function and choose the Replace option. In the Find What text field, you're gonna have to insert the country name. So I'm going to take the USA first and assign it or replace it with the value 1. And click Replace All, and it automatically encodes all the categorical values into numerical values. And you can repeat the same process for all the countries in the column. And this is the user interface of the SPSS. You can try the free trial, it's actually paid software. You can try the free trial, or you can also try the student plan if you are a student. And currently we are in the data view. There's also a second view called variable view. This is exactly where the variables are. To import a Excel file, we're gonna have to click the files and go to the import data option and select Excel or the CSV. In my case, it's a CSV file, like I mentioned earlier. It's a comma separated value format. I'm going to go with that option and I'll load that file into my session here. In the meantime, I'm going to calculate my population using the SurveyMonkey's free sample calculator. I'm going to set the population, which is 38,444, and the confidence level as 95% and the margin of error 5%. And the sample size turns out to be 381. Alright, let's get back to the SPSS session. And this is the data view when you load your CSV file into the session. And this is the variable view. As you can see, now the country is no longer a string. It's not a categorical data type. As you can probably see here, it's numeric. Even though I loaded the data set into the SPSS session, it was not sampled. So let me show you how to sample your data set. And in this case, I'm going to use random sampling. You can obviously perform random sampling here in Microsoft Excel. All you have to do is to click this cell and press Ctrl and G on your keyboard. It opens up this go-to window, and here in the reference text field you have to enter the current column and the current cell. In my case it's L2, and followed by a semicolon you have to enter the column and the maximum row number. In my case the dataset consists of 38,444. I'm gonna have to add one more to the total count since the first row is occupied by column names, and it automatically selects all the rows for you. The next step is to enter equal RANT and brackets and press enter. So this is the random function that I've used, and for each row it assigns a randomized value. And now you can use the sorting function. You can basically sort it smallest to the largest or largest to the smallest. What this actually do is that it randomizes all the rows in the entire data set, and now we can select our sample size, which is 382 participants. And now you can rename this file and open it up in your SPSS session. For perform data analysis, you have to click on this analyze option in the ribbon tab. As you can see, there's a list of options such as descriptive statistics, correlation, regression, and etc. To perform correlation analysis, you have to go to the correlate and bivariate. And now you can pull the variables into this variable tab from the list, and make sure to check Pearson because we're going to perform Pearson correlation analysis, and click OK. And this is the correlation table. As you can see, it's a negative correlation we've got here, and the correlation is significant at 0.05, which is 5%. And now I'm going to perform a inferential statistics technique, which happens to be one-way ANOVA table. Into the factor field, you're going to have to insert the independent variable and the dependent variable into the dependent list. And there's a couple of settings you have to set before continuing the process. Just simply go to the post hoc and make sure to tick 2 key, and in the options make sure to check the statistics and homogeneity of variance test and click continue, and then you can click OK. As you can see here, it automatically generates all the statistical tables for you. The most important table here is the ANOVA table. If you look at the significant value, it is stood at 0.252, which is technically greater than 0.5. And based on that fact, you can come to a conclusion that there is no statistically significant difference in satisfaction across 5 countries. And for an example, imagine 5 countries have different stores, and while the average satisfaction score look slightly different, alright, and the difference is so small it could just be down to a random luck like we learned before. And technically it is not because one country is actually better than the other. If you look at the descriptive table, This table shows the raw averages for each country. So country 1, which is the USA, has the highest average satisfaction, which is 88.69, whereas the country 5 has the lowest, which is 82.79. Put this into perspective, even though country 1 has a higher score than the country 5, the in our test, like we did before, it says 6-point gap isn't just large enough to be considered as a real difference in professional report for when we use informed decisions. Homogeneity of variances reveals the fairness of the analysis. This basically checks if the spread of the data is actually similar across countries. Just take a look at the significance value. It is 0.107. It's actually based on the mean, and since this is above 0.05, we can come to terms with the fact that the spread of the data is consistent enough and it is reliable. According to homogeneous subsets, this confirms that all 5 countries are effectively in the same league because SPSS put all countries into one single column, that's the subset 1. And for example, if you're ranking them for 2026 performance review, you couldn't just scientifically say the country 1 has successfully outperformed the country 5 because they all are statistically tied. Alright, now I'm going to go over the visual representations. I'm going to demonstrate 2 different methods that you can build visuals for these analyzed data sets. And go to the same in our table that we worked on and go to the options and make sure to check the means plot and click continue. As you can see here, for the analyzed data, it has now successfully generated a line plot. You can basically copy and paste these data visuals into your report. Second method is, you can see in the ribbon tab there is an option graphs. You just simply have to click on it and choose chart builder, and it's going to take you to this interface. On the top left corner you can see the variable list, so you just basically drag and drop the variable list. You can basically select one variable to each of these axes, and right below the preview panel you can see a tab view panel, and by default you're in the gallery. On the left, these are the types of charts to choose from. You can basically drag and drop these charts into your preview. These are other options like area, line, and the pie, polar. I'm going to stick with the bar charts. And I'm going to drag and drop the satisfaction score into the y-axis and the variable country into the x-axis. And you can change the color of your bar chart and go to chart appearance and simply select the color you prefer to go for. You can also go to the element properties just in case you want to change the title. By default, it has generated a automatic title based on the variables you have entered into the axis, and you can click on the customize just in case you want to customize the title. Now that I'm all set, I'm going to click on OK to generate the chart for me. And this is the bar chart I've generated based on the data analysis I have performed in the first place. Let's move on to the qualitative data analysis. Qualitative data analysis is the process of examining and interpreting non-numerical data. For instance, words, images, observations, experiences, in order to understand the meanings, different patterns, and themes. The primary focus of a qualitative data analysis is the perceptions of the participants. For the data preparation in qualitative research, primarily you have to ensure these 3 steps. The very first one is the transcriptions quality check. It basically involves in reviewing and verifying the written versions of the interviews and focus groups discussions or the audio recordings to ensure they are accurately reflecting what participants have said. And the second one is organizing files and folders. This step involves systematically arranging all qualitative data such as the interview transcripts, observation notes, recordings, documents into clear categories or the folders. And the third one is the familiarization. This is all about becoming deeply familiar with the dataset by reading and rereading transcripts, notes, and documents multiple times. And this is the process where the researcher begins to notice different patterns and key ideas and recurring themes. So technically, this is the core of qualitative research. And next up, we have coding and categorization. So this is pretty much like the data encoding we perform in the quantitative analysis. This process involves in assigning labels, also called codes, in order to specify the segments of qualitative data. In other words, these labels represent the important ideas and concepts and themes in the data. And these are the three main types of coding. The first one is a descriptive codes. It basically summarizes what is directly stated in the data. For an example, long working hours, customer complaints, online learning usage. And the second type of code is interpretive codes that explains the meaning of the significance behind what participants have said. For example, the work stress, customer dissatisfaction, and learning motivation. And the third one is pattern codes. It is to identify relationships and the connections between categories to form themes. Basically, this is about connecting the dots. For example, job pressure affects performance, and the technology improves learning. And the coding process in qualitative analysis can be broken down into three separate stages. And the first one being the open coding, which is also known as initial coding, where you're breaking the data into small parts and generating many possible codes. The purpose is to identify all the important ideas in the data. And the second stage is focused coding. So it is all about selecting the most relevant codes and grouping them into similar ones together. It's more like a clustering the codes. And the third one is actual coding. It involves connecting categories and identifying relationships between them. The purpose is to develop broader themes and explanations. And our next topic is thematic analysis. Thematic analysis is widely used for qualitative data analysis as a method that focuses on identifying, analyzing, and reporting patterns or themes within qualitative data. There are 6 phases in total. First one is familiarize yourself with the data. The second one is generate initial codes. The third one is for search for themes. And the fourth one, review themes. The fifth one, define and name themes. And the sixth one, which is the last phase, it is to produce and report. Now I'm going to demonstrate a real-world application using thematic analysis. And in this context, our research scenario is a researcher studies students' experience with online learning using interview data. As the first one, the familiarization with data, the interview excerpt says that online classes are convenient because I don't have to travel, but sometimes the internet connection is unstable and I lose focus. And researcher would read this multiple times and note key ideas: the convenience, no travel, internet problem, and loss of focus. Second one is to generate initial codes. So the codes are assigned to meaningful segments of data. Learning convenience, time saving, technical issues, concentration problems. And the step 3, search for themes. All these related codes are grouped into broader themes. For example, these are a set of codes: learning convenience and time saving. The theme can be generated the benefits of online learning. And the second one is technical issues, concentration problems. And the theme would be the challenges of online learning. And the step 4 is review themes. This is where the researcher checks multiple transcripts to confirm this theory. In this step, the researcher has to be logical enough to think and ask these questions like, do these themes appear repeatedly, and do they represent participants' views accurately? This step is very important, and asking questions and be logical enough to notice the differences are also important because the themes are confirmed as the valid patterns of this study. And step 5 is define and name themes. For an example, the theme name benefits of online learning. The definition would be the advantages such as convenience, flexibility, and time saving. And the second theme name could be challenges of online learning. And the definition, the barriers such as technical issues and difficulty concentrating. And the last step, the step 6, is produce and report. And this is where the researcher reports findings based on the supported evidences. For instance, their students highlighted both benefits and challenges of online learning, and many participants describe online classes are convenient and time-saving, while unstable internet connection has created learning difficulties. So basically, in thematic analysis, this is the flow, starting off with raw interview data, and again it goes to the codes, and it generates categories, and it generates themes, and finally the research findings. There are also other qualitative approaches such as content analysis, grounded theory, narrative analysis. So I highly recommend you to go through all these analysis approaches. So feel free to download this document from our official website. There are also software tools available for qualitative analysis. The most common tools are NVivo, Atlas TI, and MaxQDay. We will provide you with the resource links for each of these tools. We encourage you to find out the best fit for yourself. Alright, let's move on to the mixed methods integration. Mixed methods integration is a research approach that combines both quantitative and qualitative methods into a single study. So the purpose here is to gain more complete and deeper understanding of the research problem by using the strength of both approaches combined. We basically use mixed methods for the following purposes. And the first one is triangulation. This is ideal when you want to confirm or validate findings by checking consistency across data sources. For an example, a researcher studies student satisfaction with online learning using a survey for numerical ratings and interviews for non-numerical ratings. And just in case both methods show students are dissatisfied with the internet quality, the findings will be validated. And the second purpose is complementarity. That is for using different methods to explore different aspects of the same phenomenon for richer understanding. For an example, a survey measures how many employees experience job stress, while interviews explore why they feel stressed and how it affects them. The third purpose is development. Basically, it results from one method to help design or guide the other method. For an example, a researcher first conducts interviews to identify important issues in online learning and then uses those findings to create a questionnaire for a large survey. And the fourth purpose is the expansion. So it's basically extending the scope of research by examining different components of a problem using different methods. An example would be a study that measures students' academic performance quantitatively and also explores their personal learning experience qualitatively to broaden the research. There are two strategies that we can use in this mixed method integration, and the first strategy is the sequential design. So one method is conducted in the first place and it's followed by the other. Therefore, the results from the first phase guide the second phase. For an example, a researcher conducts a survey on customer satisfaction as a quantitative approach, then interviewed selected customers quantitatively to explain survey results. And the second integration strategy is concurrent design. It's a collection of both quantitative and qualitative data on the same mark and later combine them all together. For an example, a researcher distributes questionnaires and conduct interviews simultaneously to study employee motivation. So here we have a practical example using both quantitative and qualitative methods. So this is a research regarding student experience with online learning. As a step 1, the quantitative phase, the survey, 200 students complete a questionnaire rating satisfaction on a scale of 1 to 5, and the results show low satisfaction regarding the internet connectivity. And in the second step, which happens to be the qualitative phase, using interviews as the method, the researcher interviews 15 students out of that group, and students explain that slow internet causes missed lectures and frustration. The integration findings, the survey shows what the problem is, which happens to be the low satisfaction, and interviews explain the cause, as in why the problem exists. In this case, it's due to the internet-related issues. When both are combined, the combined results provide a deeper and more reliable conclusion. And this is the basic picture of the mixed method integration. So mixed methods integration combines numerical results and detailed explanation, improving validity, providing deep understanding, and offering more comprehensive research findings. Let's move on to the next topic, interpretation of results as post-analysis proceedings. So this is all about explaining how your research findings actually show and how they answer your study goals you set in the first place at the very beginning of your research. Because it is important to provide a meaning to your numbers generated from the analysis process. You can basically use these 5 steps. So the first one is connecting findings to research questions. This is where you clearly show your results in a way that can trace back to your original research questions or the objectives. You can basically address every research question one by one and use your collected data, statistics, and survey results and observations as evidence, and compare your findings with previous studies or theories from the literature review, and explain whether your results support or contradicts earlier research. So for an example, if your question was about customer satisfaction, so you can explain what your data shows about satisfaction and how it relates to existing studies. As a second step, you can discuss about the implications. And for example, you can explain why your results matter. From a theoretical perspective, you can discuss how do your findings support and challenge or extend existing knowledge, and whether you should confirm or question existing models or assumptions. From a practical perspective, you can discuss about how organizations and professionals or society can use your results, along with what improvements or actions should be taken. And for recommendations, suggest practical solutions based on findings and provide realistic applications of your research. And the third step is to acknowledge your limitations of your study. So every study has their weaknesses and researchers must openly discuss about them. In common cases, the limitations may include sampling limitations, such as a small sample size limited to the population, and maybe even biases, and the measurement limitations, such as inaccurate tools or unclear survey questions, and also the design limitations, such as the time constraints, method weaknesses. And it is also advisable to explain how these limitations may affect your results, as well as how future studies could improve them. Because it's worth remembering that being honest increases research credibility. And the fourth step is drawing valid conclusions. It's important to notice that your conclusions must match your evidence. When you're drawing the valid conclusions, you should not exaggerate your findings and clearly separate correlations from the causations. And consider other possible explanations for your results. Also base conclusions only on what your data supports. And the fifth step is handling unexpected findings. It is more common to be able to find surprising results, and those results are also valuable. So do not ignore them, suggest possible reasons for unexpected outcomes, and compare them with the theory or previous research, and recommend further investigation just in case it is highly required. And that is due to the fact that the unexpected results have a possibility of leading to new research ideas. Here we have an example. The scenario is about a researcher studies the relationship between study hours and academic performance among university students. There are 3 main research questions. The first one is there a relationship between study hours and exam scores? And the second one, do students who study more perform significantly better? And the third one, what are the practical implications for student learning? And the sample size is 120 students, the variables, the study hours per week, and the exam scores. According to descriptive results, the interpretations will be that students studied about 15 hours per week on average, and the average exam score was 72.6%, and the large standard deviation shows difference in performance. So their findings have a connection back to the research question. The statistics describe the general student performance and study behavior. And the correlation analysis revealed that the Pearson correlation of 0.68 and the p-value significance of 0.001, and the interpretations turns out to be the strong positive relationship between study hours and exam scores, and students who studied more generally achieved higher scores. And since the p-value is less than 5%, the relationship is statistically significant. And that traced back to the original research question, which is the question 1, Study hours and exam scores are significantly related to each other. According to the interpretations from the t-test analysis, students who studied more scored significantly higher, and large effect size shows strong practical difference. And that interpretation can be traced back to the original question too, and validate that studying more significantly improves exam performance. In the implications discussion, from a theoretical perspective, it supports learning theories suggesting efforts improves performance, and it also confirms previous research linking study time to academic achievement. In a practical perspective, universities should encourage structured study schedules, and academic support programs may increase student performance. And as practical recommendations, provide study planning workshops and implement time management training for students. As the third step, acknowledging the limitations, the sample limitations, because these students are only from one university, and the measurement limitation, study hours were self-reported, and design limitations, the cross-sectional study, because it was conducted at one point, and that builds effects on the interpretation, such as the results may not generalize to all students, and self-reported data may contain bias, and it's also almost impossible to confirm long-term effects. The fourth step is drawing valid conclusions, because the study shows a strong relationship between study time and the performance. However, correlation does not prove causation, so other factors such as intelligence, motivation, and the teaching quality may influence the results. You can also introduce an alternative explanation to this. For an example, high-performance students may naturally study more. And unexpected findings could be some students studying many hours and still perform poorly. And for that cause, you can introduce some possible explanations such as ineffective study methods and stress or poor time management, and quality of study may matter more than quantity. And finally, you can introduce future research suggestions such as study the effect of study technique on performance. And you can introduce the final research conclusion that the findings show a statistically significant and strong positive relationship between study hours and academic performance, and students who studied more achieved high exam scores. And it suggests that the behavior plays an important role in learning outcomes, and however, due to limitations such as self-reported data and cross-sectional design, causal conclusions cannot be made. And for that, future research should examine additional factors influencing academic performance. Alright, and now we have come to the end of our third video tutorial in the tutorial series for academic research. In this video, you learn all about data collection and analysis process. In the chapter 8, you went through the quantitative data collection, and in the chapter 9, you went through the qualitative data collection, and in the chapter 10, you'll learn how to perform data analysis based on these quantitative and qualitative data collection. In the next video, you'll be learning the writing and the publishing process of your research work. So subscribe to the XIVIX University channel and turn on the notification bell so you'll get notified once we post our next tutorial in this series.